Hello. Today I'm going to talk about something called the unit circle. And the unit circle is a very important aspect of trigonometry and one that you'll become familiar with quite soon. So the unit circle is exactly as it seems. It's just a circle on a graph of x and y at a radius of 1. So this point is 1, 0, right, in coordinates. In 1, 0, 0, no, oops, 2, negative 1, 0. This is just in the Cartesian coordinate system, right? 0, negative 1. And that's good, right? But what does this have to do with trigonometry exactly? So, trigonometry is about right triangles, right? But so is a circle. A circle's equation is y squared plus x squared is equal to r squared. And guess what? How similar is that to a squared plus b squared is equal to c squared? That's the Pythagorean theorem. So a circle is just made up of, you could say, an infinite number of these little right triangles, where this is some x value, as this is some y value, and you decide the r value, that's a constant. And that's really all it is. That's what a circle is. So let's undo that. And there are so many of those little triangles all around, and every time that one is correct, you find the x and y point to get a point on the circle. See, like this is a point, this is, say, a point that would fit. This is some x and some y that follow that. This is some x and some y. And one r that you choose, right? There's only one radius in a circle. Unlike an ellipse. Hyperbola. Alright, so that's great. So a circle is made of triangles. So this must have something to do with trigonometry. And yeah, you could guess it does. So in trigonometry, we use sine, cosine, and tangent. Let's write our old SOHCAHTOA up here. SOHCAHTOA. And the sine is the opposite over hypotenuse, the cosine is the adjacent over hypotenuse, and the tangent is opposite over adjacent. They're ratios. So what would happen if we were to have these in our circle? Well, let's find out. I can erase some of these. So let's say we have some angle here in radians. This is angle, let's just say theta for now. We're not going to specify that angle. What's the sine of theta? The sine of theta would be the ratio of this opposite side to the hypotenuse. And what's the hypotenuse? Well, that's the radius of the circle. That's 1. Because it's a unit circle, it has radius 1. That's what unit circle means. So the sine is this opposite, which is our y value over 1. Alright, so sine theta is equal to y over 1, and that's just equal to y. Our y coordinate. That's equal to this y here. Alright, what's our cosine? Well, that's the adjacent side of our hypotenuse. That's x over 1. Alright. So the cosine of theta is equal to x over 1. Just equal to x. So that's the same as this. And why does this matter? So what? We found ratios inside the circle. Who cares? Well, let's say we knew an angle, but we didn't know its sine or cosine. This is a really easy way to find the sine and cosine, because notice, the sine of any angle in a unit circle is equal to y, the y coordinate, y, just going to write coordinate that it hits the circle at, right? So this y coordinate, and the cosine of any angle is just equal to the x coordinate that it hits the circle at, right? So here, so you could just say this here, where you are along the x when you hit the circle, and where you are along the y when you hit the circle, right? So that's pretty cool. Now we can just put any theta in there and find sines and cosines. And you can also notice that the tangent is y over x. We'll get to that later. Now, for some other just simple rules in the unit circle. For one, the unit circle always goes anti-clockwise, so we always go this way when doing angles. If we go the opposite way, we're taking negative angles. So this is positive 2 pi radians. If we went the opposite way, that's negative 2 pi radians. And notice, if we go positive that much and then negative that much, we get back to 0. We just add the number of radians we've gone to find our final degree. And there are some more I'm going to teach you right now. Alright, so what are some other rules for the unit circle? For one, if we're counting positive degrees, positive theta, we're going anti-clockwise or counterclockwise. If we're going the opposite direction, we're going negative degrees. So, right, this is 30 degrees, and this is negative 30 degrees, if we're working with degrees. And we can still work with degrees from now and then, if it's easier. That's okay, it's just that radians are more useful. And let's practice with this whole new sine cosine thing that's so easy. So we know the sine of 30 is 1/2. What's the sine of negative 30? Well, we know that because the sine of 30 is 1/2, this point will be, what will it be? For which one? So the sine will be the y coordinate, and the cosine will be the x coordinate. So what's our cosine? That's the square root of 3 over 2. And what's the sine? That's 1 over 2. So this is the coordinate that we're at. Cosine, sine. It's cos 30. While this one is sine 30. Alright. So, does that go the same for this one down here? Well, this one, I drew it really badly. It should be more down here. Are these congruent triangles here? Well, 2 same sides, okay. 1 same angle, and another same side. SAS congruency, because the radius is the same. So by, SAS congruency, yes. These, let's call it like, we can call this O for origin, A, B, and C. So triangle, getting into geometry now, OA, B is congruent, it's congruent sine, the triangle, OBC. I'm not great at using the notation, but this is basically it. Except that this angle is going downwards, so the y coordinate will just be negative. So we'll have normal square root of 3 over 2. We're going to go space. Negative 1/2. Because we're just flipped. So if we go in negative degrees, we're going to have in this, right? You know the quadrants. 1, this is, by the way, why the quadrants are labeled this way. 1, 2, 3, 4. If we're in the fourth quadrant, and we take the sign, we get a negative y value and a positive x value. If we're in the third, we get negatives for both. If we're in the second, we get negative x but positive y. And if we're in the first, then we get positives and positives. So, right, we get positive x, y, negative x, positive y, negative x, negative y, so negative x, y, and positive x, negative y. So the unit circle is just a really useful way to visualize sines and cosines and get an idea of what they really mean, and that it's really just part of the Pythagorean theorem. Thanks for watching.